Okay, let's welcome to the machine learning with the really unique. Okay, today we are going to learn about the Siemens neural network. Siemens neural network, sometimes it is also known as twin neural network, is artificial neural network that uses the same weight while working in tandem on two different input vector to compute the comparable output vector. Working in tandem means working alongside with each other on two different so same weight is working together on two different input vector to compute the output vector. Often one of the output vector is pre-computed, thus performing the baseline against the other output vector is compared. This is similar to comparing the fingerprints but can be described more technically as distance function or locality sensitive hashing. It is possible to build the architecture that is similar to the Siemens network but implements a different function. This is typically used for comparing the similar instances in a different type sets. Uses of similarity measures where the twin network might be used are such things as recognizing the handwritten checks, automatic detection of faces in camera images, matching the queries with the index document, and perhaps the most well-known application of the twin network are face recognition, where the images of the people are pre-computed and compared with the images from the cross-Nile are similar. It is obvious at first, but there are two slightly different problems. One is the recognition of the person among the large number of persons. That is the face recognition problem. The face is the example of the such system. In most extreme form, this recognizing a single person at a train or airport, the face other is face verification. That is to verify the photo in the past is the same as the person who is claiming to be a same person. The two network might be same, but different implementation can be quite different. Learning in the twin network can be done in the triple lost or the constructive function. Constructive loss. For learning the triple loss of baseline vector, anchor image is compared with the positive vector and the negative vector. Basically, it is also what learning algorithm that uses the similarity matrix rather than the classification problem. It works based on the similarity function. So it uses the triple loss, which is the which we have learned in the previous video. You can check that video in the play that is video in the playlist if you have not gone through it. It works on the triple loss or the constructive loss. The negative vector will force the learning in the network, while the positive vector will act as the regulator. For learning the constructive loss, there must be a weight decay to regularize the weight, or some operation like normalization. A distance metric for the loss function may have the following properties: non-negative, distance between the source that the uh, distance between x and y is greater than 0, identity are non-discernibles such that these are the conditions such that the is equals to 0 and x is equals to y. Symmetry, that means x and y, function of x and y is equals to y comma x. Triple equivalence, you know what it means. There are the 3 point x and y, x and z is less than or equals to x and y plus function of y and z. In particular, triple loss function is often defined with the Euclidean distance. Unlike Euclidean, that does not have triangle inequality distance at its core. Predefined matrix. The Euclidean matrix. It is the Euclidean matrix distance between the 2 points. The given function is given by id. There is a x point and x. I and j are the indexes of the vector. We are trying to minimize the distance or maximize the distance. Minimization is if I is equal to j means that it's in the same points. That means x and y is equal to the same point that gives the zero. So we are trying to minimize these because the it gives the, and we are going to maximize the distance between the two different points. Lone matrix, non-linear matrix, a more general case is the output vector from the twin matrix is passed through the additional neural network, implementing the non-linear distance matrix. If I is equal to j, then f of xi and f of xi is small, otherwise that is large. This function is implemented by the twin vector network, and this function is implemented by the joining the twin vector. Lone matrix. Let's dive together in the last form of the what is the use of the twin networks or same as neural network. Twins networks have been used in the object tracking because of its unique two tandems in input and similarity measurement. In the object tracking, one input of the twin vector is user pre-selected exemplary image, and the other input is the larger source image, which is twin network job to locate the exemplar inside of the source image. By measuring the similarity between exemplar and is part of the source image, a map of the similarity score can be given by the twin network. Furthermore, the fully convolution neural network, the process of the computing the each sector similarity score can be replaced by the one correlational layer. After being introduced in 2016, twin fully convolutional convolution networks has been used in many high performance real object tracking neural networks such as CEFNet, Stoxium, Stoxcf-Tri, DCM, CMMAX, CMRPN, plus deeper, wider, yes, RPM. And this was today. Hope to see you in the next video. Thank you.